There are several useful acronyms that can help us remember information about the OSI model. To remember the names of the layers, there are two acronyms. For layer 7 through 1, we can use All People Seem to Need Domino's Pizza. And for layers 1 through 7, we can use Please Do Not Throw Sausage Pizza Away. To remember the names of the protocol data units, we can use the acronym Domino's Should Provide Free Breadsticks. Now we will talk about the individual layers of the OSI model.
Layer 1 of the OSI model is the physical layer. The physical layer encodes the data that's in the form of zeros and ones into the form of which the device uses to transfer data. The three common methods the data is transferred through the physical layer is by using a network cable, which encodes data into electrical signals, fiber optic cable, which uses pulses of light, and/or a wireless router, which transfers data in the form of radio waves. Problems that can occur in the physical layer are often caused by electromagnetic interference, noise that scrambles the signals, broken cables, and misconfigured or faulty network interface cards, hubs, and switches.
Okay, so now we move on to layer 2, which is the data link layer. At this layer, data packets are encoded and decoded into bits. It furnishes transmission protocol knowledge and management and handles errors in the physical layer. Flow control and frame synchronization. The data link layer is divided into two sublayers: the media access control (MAC) layer and logical link control (LLC) layer. The MAC sublayer controls how a computer on the network gains access to the data and permission to transmit it. The LLC layer controls frames, synchronization, flow control, and error checking.
The third layer of the OSI model is the network layer. The network layer handles logical addressing, translates logical network addresses into physical addresses, and performs the best path selection and routing in an internetwork. To support routing, the network layer maintains logical addresses such as IP addresses for devices on the network. Some of the protocols that work on this layer are IP, ARP, and ICMP. The network layer also manages the mapping between these logical addresses and physical addresses. In IP networking, this mapping is accomplished through the Address Resolution Protocol, ARP. The routers will operate at this level of the OSI model, and the router consults a list of rules before forwarding an incoming packet to determine whether a packet meeting a certain criteria should be permitted through or not. This is called access control.
The next layer of the OSI model is called the transport layer, which is also known as the segment layer. The transport layer manages data transfer from one application to another across a network by breaking down data into smaller chunks called segments. Every segment has a maximum frame size called the maximum transmission unit. There are two protocols that work on this level, TCP and UDP. TCP, which is also known as, is connection-based and is used to make sure connection will not be lost in the transmission. The other one is UDP, User Datagram Protocol. It is connectionless and is an alternative to TCP. UDP is not as reliable as TCP, but it's better with latency, where latency might be an issue, for instance, voice over internet protocol, or maybe, perhaps, games.
Layer 5 is the session layer. The EDU in this layer is data. The session layer provides communication between two computers over a network, allowing the exchange of data. It handles communication setup, session teardown, name lookup, and user logon and logoff. Some protocols that work at least partially in this layer are DNS, FTP, and NFS.
So after layer 5, which is a session layer, we move on to layer 6, presentation. This layer provides independence from difference in data representation, e.g. encryption, by translating from application to network format and vice versa. The presentation layer works to transform data into the form that the application layer can accept. This layer formats and encrypts data to be sent across a network, providing a freedom from the capability problems. It is sometimes called the syntax layer.
Layer 7 is the application layer. This layer is the layer closest to the user. The protocol data unit in this layer is data. The application layer provides interfaces for applications to access network services, handles error recovery, identifies communication partners, determines resource availability, and synchronizes communication. Protocols at this layer include HTTP, HTTPS, FTP, SMTP, and TFTP.
And that concludes this presentation of the OSI model.